Morning, kiddos. Today I'm going to reverse engineer a power supply. This is actually a Dell desktop power supply. I'm going to use these on my manufacturing stations that we're creating in the classroom. They provide multiple power voltages, DC actually. I already have on the manufacturing stations 24 volts AC, so that's enough for what I need when I'm using AC components. I also want to run some items using DC voltages as well. And one of the good things about power supply inside a desktop, a tower, is that a lot of the components inside of it is ran with DC power. It takes AC, converts it to DC. And these are the things that are plugged into your motherboard, your hard drive, and your CD drive, and other components that is powered up. And the voltages that they use on these power supplies is 12 volts DC, positive 12 volts DC twice, and they use a 12 volts negative, a negative 12 volts DC. Also, they use 5 volts in the system, and they also use 3.3 volts. If you've done the Arduinos with me in classroom, if you'll notice that you have 12 volts and you have 5 volts and 3.3 volts on them to run items. Okay. Well, the computers does that too. And if you didn't know this, but on your laptop, you have a box on the cord. You know how you go from the wall, it goes to a square box, and then from the square box, you go to your laptop. That square box is the same thing as this power supply that's inside the tower, except it's just inside. It's a smaller version of it, but it basically has the same outputs. It provides 12 volts to the laptop, and matter of fact, if you'll notice that when you use your cigarette lighter in or your power. Used to call it cigarette lighters, but I don't know if they're not used as cigarette lighters anymore. But a power source. When you plug in the power source in your car, it's just a straight cord to go straight to your laptop. Because the reason why is the 12 volts is provided by the car from your battery, basically. That's being the 12 volts is coming from the car battery. All right, but and in the house, we have AC. So what it does is it takes the AC and converts it to DC. And that's what that little black box is on the cord, is a power supply. And it just converts the AC into DC. And that's what it's doing. This is a bigger version of it. They don't have to be so compact with this one because it's actually inside a computer tower. So I want to use the voltages in here. So I'm going to double check. I want to know what the voltages are on each one of these wires and what colors represents what. And first I did some investigating, and you can. And this is the label on the power supply. And if you notice on the power supply, it provides you the different voltages that is coming, the output voltages up here. Output voltages, and here they are down here. Okay, if you notice this line with a little dash underneath it, that means it's DC. That's the symbol for DC. If it was AC, it'd be like a wave, like a rounded wave. All right, well, I've already went through there and looked on the PC board and got the colors of each one of these voltages and wrote them down. And now what I'm going to do is double check it. And another thing you need to be aware of it's hard to do, is right here where it says maximum continuous load, and they put it in wattage on both of these here. Is the reason why you need to know that is you don't want to overwork the power supply. There's a maximum amount of amps that can be pulled from this power supply. If you overdo it, you can burn up this power supply. So we have to be controlled. But right now we're not going to be able to check the amps on this thing, but we can check the voltages and to see what color the wires are. The only way we can actually check the amps is by putting a load on it and seeing how well it's performing under a load. All right. But right now, we're going to reverse engineer the voltages, and we're going to double check my color chart right here on what's coming out of the power supply. All right. Okay. Now here we go. One of the things we need to remember about a power supply is when you plug it in, it's got high voltages that can you can be electrocuted, or it can kill you actually. So we want to be careful when we're checking the voltages on here. So on these power supplies, they usually have a switch here that keeps the power supply off until you actually plug it back into the casing, so you don't accidentally do any damage to the power supply. So I don't have a whole lot of hands, so what I'm going to do is I'm going to use this clip and put on here to hold it, and then I'm going to take the cord and I'm going to plug it in. And then after I plug the cord in, I need to be extra careful what's happening. But if you'll notice on the power supply, the light came on. So now we have power. If I take this off, you'll notice that light will go off. And then if you was to try to check voltages, you're not going to find the DC voltages on here. But you will find the AC voltage in here at a certain point, but you will not see the DC voltage. So that's why we're using the clip to turn it on. All right. I know in here, I've already checked the colors on here, and I know black is ground. So on the black, we're going to hook, but ground is also connected to the frame. So it's hard to get to the black wires here and touch it because you might short something out, but you can literally clip to the frame and get the same thing. And I'm going to show you. But first, I forgot one step. I always check my meter. And then on your meter, if you'll see the continuity checker right there, what we're going to do is make sure our leads are having good connections. So when we go check the voltages, on there, that we know our leads are not damaged or malfunction. Okay, so here on go. So I'm going to check to here, and you hear that noise? It means that we have no obstruction or resistance to it. Okay, so now we're going to set it on DC voltage. Remember, we're checking DC. Remember that little symbol I showed you, that those dotted lines on the bottom and the long line at the top? That means DC, all right? So we're going to hook up to the ground. So we should have ground. And on my piece of paper that I wrote on here, I said that the yellow wire is 12 volts. So that's what we're going to look first. So here's the yellow wires. So when I put it to here and touch it on the meter, if you can see the meter, maybe if I put a clip on it, make it where it makes it easier to see. Where's the big one? Oh, maybe to hold it. Okay, there we go. So when I touch the yellow wire, we should see about 12 volts or close to it. So I'm going to the yellow wire here, the pin's up here, and I'm going to touch it. See, it says 11.3, 11.9, 3.2. They're accurate within about 2 to 3%. Okay, so the meter's accuracy has a lot to do with what we show up on here, and how the good of ground we get as well. And if you notice, the black wires here is ground. So if we touch the ground, we shouldn't get no reading at all. You just say 0. But the yellow wires, we should get 12 volts, and that's close enough. 12 volts. Okay. Also, we said on here that white right here is also 12 volts. So let's check the white wires. On here, there's a little weird connections here where it's like a wedging process to make the connection of the wires. You have to take the cap off so you can get to the wire. So I'm going to the wire, and here's the white wire, and I'm going to touch it. You notice it has the same amount of voltage, so that's right. Okay. And we said that red, I looked on the PC board, and it says that red is 5 volts. So when we go to the red wire, here's the red wire. It didn't show up. So am I making good enough contact? There's 5 volts right there. Okay. And we said orange on here is 3.3 volts. So let's check that. Here's the orange. And we have 3.3 volts. So the white was, let's see, 12 volts. The orange was 3.3 volts. The red was 5 volts. And see, it has 2 black wires. You remember what I told you? Black wires are ground, so you should not get no voltage at all when I touch it. It should say 0 because it's the same leg. You know, putting power back into the same power, you're not going to get anything. It's just going to be the same power, right? We also have the other one, so they should be the same. So here's orange right here. These 2 pins here is orange, 3.3. So it's right. And there's a blue wires and stuff we're going to check later. But these top 3 right here says it's red. So what was red? Does anyone remember? Red. It was 5 volts. So all the red wires should be 5 volts. And all the black wires should be ground. And the orange wire should be what? 3.3 volts. Which we have. So this power supply is doing exactly what it's supposed to do. I'm going to check this blue wire and see what we get out of it. See if it's any 12 volts out of it. Actually, it does. So it is 12 volts DC. What about the green wire? Nothing. That means, usually, that it's the same voltage if we don't get anything out of it. All right. There's a gray wire down here. Let's see what the gray wire says. The gray wire says almost 5 volts. Okay. There's white down here at the bottom. And it says 12 volts. The reason why it's beeping is it starts going up to high voltage and then drops back down to low voltage. This meter will tell you when you're touching high voltage. For instance, over here on the cord, I don't know if you can see it. This is where the power supply comes in. And if I was one, that's AC. So we need to switch it to AC. And if I touch right here, I'm on the same leg. So that means it's the other side is the hot leg. And I'm not touching it very well. Ouch. That means I don't have a good enough ground. So, but the point is, if I touch that with the AC voltage, that would show 120. Actually, I can take it off here and show you what's coming in. And do it like this. Use the lead, different lead, and just come straight off of it. So if I put that in there and plug that in there, hear that noise? That red light's coming on. It's saying, hey, I got high voltage. This could kill me. This has got enough current and voltage to kill me. Actually, it only takes 0.75 milliamps to stop your heart. But a lot of times, the lower the voltage, the harder it is to get through your skin. But the higher the voltage, the easier it can get through your skin. And 120 can get through your skin. And so you can get definitely enough current across your heart to kill you at 120 volts. All right. Hopefully it was a little fun little activity to show you how to reverse engineer a power supply. Again, we're going to use these on our manufacturing stations to provide 12 volts, 5 volts, and 3.3 volts to components that we're going to use on our manufacturing stations. Y'all have a good evening. Bye.